question is from the homework Review 3 for the integral calculus, and it's question number 11b in the volume section. And 11b says we have f of x equals sine x, g of x equals log x, and we want to find the area in here or the volumes that are made from this area in here. Okay, so the first part of it asks us to solve for the value of that intersection, and we need to use our graphing calculator to do that, or graphing tool. And this intersection point works out to be x equals 2.22. And so that's going to split up our integral into two areas. So if I want to find out the area R, so this is the area R, that area R is going to be broken up into two parts. It's going to be broken up into this part here that's under the log function, and then it's going to be broken up into this part here where it's under the sine function. Okay, so we need to then set up that integral. So I'm going to set up the first integral. So the area that would calculate the area, or the integral that calculates the area R, so this is part 2. That's going to be the integral, so R is equal to the integral from the intersection point, so the 0 of that log function is 1, the 0 of the sine function is pi. So for the first part, it's going to be from 1 to 2.22, and that's going to be under log x dx. So that is representing the yellow portion here. Okay, and then for the next part, we want to add onto that the integral from 2.22 to pi, and that's going to be underneath the sine x function. So we do sine x dx, and that's representing the blue area there. Okay, so that's part 2. Okay, so part the 3 says that the area of this base represents the solid with cross-sectional perpendicular to the x-axis are equilateral triangles. So basically what's happening is, out of this base, so if we take that section there, we have equilateral triangles coming out of that. So we want to find the volume made by that shape. Okay, so 3 is going to be the volume. And to calculate the volume of that shape, what we want to do is find the area of the triangle and then multiply it by some thickness dx. And we're going to do that from 1 to 2.22. So for the area for the triangle 1, we'll call triangle 1 plus the area from 2.22 to pi, and the area of triangle 2, this is the area is just going to be made by the blue. Okay, so multiply that by dx. Okay, so we need to find the area of that equilateral triangle. So there's a few ways you can do this. The area of the triangle can be found in this way. So if this is equilateral triangle. If I want to find the equilateral triangle, the base length is going to be the y value from here to here. Here are the function value. So that's going to be y, y, y. To find out the area of this triangle, we need to find the height. Okay, so the height of that is going to be root 3 over 2y using our trig, our special value triangles. And so the area of that triangle is going to be y times root 3 over 2y divided by 2, so that area of the triangle simplifies to root 3y squared over 4. So that's how we can work out the area of the triangle. Regardless of whether it's on this side here or this side here, that area of the triangle is going to be based on that. The y value is going to be different depending on which region, yellow or blue, we're dealing with, but the area of the equilateral triangle can be found that way. Now, that's one way. The other way is we could use Heron's formula. So if you don't know Heron's formula, you can't use it, but if you know Heron's formula, Heron's formula looks like this. The area of the triangle is equal to the semi-perimeter, the square root of the semi-perimeter times s minus side A, s minus side B, s minus side C. And the semi-perimeter is basically half of the perimeter. Okay, so in this case here, it's just going to be 3y is a perimeter, and so the semi-perimeter in this case is going to be 3y and take half, and that's our semi-perimeter. So if I plug it into that formula, there this triangle works out to be the square root of the semi-perimeter 3y over 2. And so A, B, and C represents the side length, so it's just going to be y. So we end up with 3y over 2 minus y, 3y over 2, sorry, that should be 3y over 2 minus y, and then 3y over 2 minus y. Those are just all 1/2 y's. So simplifying this, we end up with 3 over 2y times 1/2 y times 1/2 y times 1/2 y. And then simplifying this further, I end up with 3y to the power 4 over 16 square root. When I square root that, I get square root 3 over 4. Square rooting y4, I get y squared. So I end up with the exact same equation. Okay, so regardless of if I use Heron's formula or just use a triangle here, we're going to get the same area. So I'm going to use that same area then to calculate the volume. The volume is going to be, the area of the first one is going to be from 1 to 2.22, and I'm going to use this expression for the area of that triangle. So since I can factor that out, I'm just going to factor that out and do it like this. That just avoids all those terms. So it was from 1 to 2.22, and then I'm going to use y squared. Well, y for the first part, that y is going to be the log function, so it's going to be log x squared dx, plus the second part is going to be 2.22 to pi. In this case, it's going to be sine x squared times dx. So there works, that integral then will work out the value of the volume made by those triangles sticking out of there. Okay, so notice that the area that had root 3 over 4 in common, I just factored that out here to kind of clean it up a bit, but you can leave that in there if you like. So there is the volume of that area. Sorry, that's the integral that will calculate the volume.